Alright, we're going to do a little lesson on 5.2, which is exponential functions and their graphs. An exponential function is one that's growing. You know, we talked about linear function, that's a line, and you've had quadratics and cubics. An exponential function is going to be one that grows, in other words, exponentially. It goes up or it goes down really at a fast rate. Like sometimes we can talk about diseases growing exponentially, or if you're studying in chemistry, you can look at the half-lives of different elements and things like that, and that would be an exponential function as well. We can talk about compound interest is an application of an exponential function. So there's all kinds of applications of exponential functions. Sometimes in exponential functions we use the number e. Now if you have a calculator, you can look up the value of e. It's a little more than 2.7. It's right here. So on a home screen, if I clear this out, if I go type in what is e to the first, it's around 2.71, and it keeps on going and going and going. You can't, it's a number that's not going to end. Now, if we're looking at that on a where they came up with that number, if you take a look at a compound interest formula, if you do 1 plus 1 over n to the n, if n is 1 and we evaluate this, so if I plug in 1, I get 2. If I plug in 3, I'd get like 2.37. If I plug in 100, I get 2.7048. And if I keep going up and up and up, I'm going to get really, 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 really close to, as my numbers approach infinity, I'm going to get really, really close to this number e. And it's been around for years and years and years. So it would work like a horizontal asymptote on this exponential graph. And so it's going to be important. And so some of your questions may ask you to evaluate evaluate powers of e. So that may be something you'd have to do, but it's just using that key on your calculator. So let's look at how do we do a graph of an exponential function. Alright, so basic exponential function is just going to be of the form f of x equals a to the x. And the a value is always going to be bigger than 0, and it can't equal 1. So this is going to give us some numbers, and we can figure out different properties of this graph. One thing I know about every exponential graph is that they're always continuous, meaning you're not going to pick up your pencil. There's not going to be any breaks in the graph. Whenever it starts, then you're just going to continue with your pencil. They're going to be continuous. They're also all going to be one-to-one, which should tell you something from the last section. If they're one-to-one, you can find the inverse, right? The domain of these functions are always negative infinity to positive infinity. That's your domain for every exponential function. The range for a basic one, unless there's some shifts or something like that, is going to be from 0, can't touch 0, but from 0 to infinity. If my a value is bigger than 1, it's going to be an increasing function. And if my a value is between 0 and 1, like maybe it's a half or a 3/4, it's going to be a decreasing function. You'd have a horizontal asymptote at the x-axis, and the y-intercept is always the point 0, 1. Now what I would do is then I would graph that function. So let me just look at a couple different ones similar to this. So let's say I had f of x equals, let's say it was 2 to the x. F of x equals 2 to the x. And they wanted me to graph that. Well, remember I said it was continuous. It always goes through the point 0, 1. It's also going to go through the point 1, 2. If x is 1, 2 to the first will be 2. So it's going to go through the point 1, 2. So 2 key points to remember is always 0, 1, and 1a. So what will happen, remember the x-axis is my asymptote. So this graph is going to end up going through 0, 1, and 1, 2, and then going up. If I had f of x equals 3 to the x, it would go through 0, 1, and 1, 3. So I would hit both of those points. It's an increasing function, so it's going to be going up. So then I could draw that graph. If it was f of x equals 1 half to the x, 1 half, that doesn't look very neat, it would go, now that would be a decreasing function because 1 half is smaller than 1. So that's going to go through 0, 1, and 1, 0, 1, and 1a, so 1, 1 half. So it's going to go through 0, 1, and 1, 1 half. So this graph is going to be going, ooh, I don't want to touch the x-axis like that. So it's a decreasing function. That's not very good, but it's smooth. Hard to make this line do what I want it to do. But approaching that x-axis. Now, as we've had with other graphs, we can have some transformations of these functions. So let's say, what if I were to have f of x equals 2 to the x minus 1. Now, just like we studied several chapters ago, when things happen here, it's moving your graph left and right. If it's added onto the end, that would be the up and down. So what this would be is it'd be the graph of 2 to the x moved 1 unit to the right. If I had f of x equals 2 to the x plus 1, that would be the graph of 2 to the x moved up 1 unit. All of the rules that show you which way to move it are in your textbook. Let me figure out what page you may want to find that on. They say to go back to section 2.4, which is on page 204 in your book, to review all of those transformations we learned earlier this year. So let's look at a few more examples here. What if I were to have f of x equals, let's see, how about problem 32, 2 to the x minus 1 minus 3. Well, I'm starting with the basic graph of 2 to the x. The minus 1 up here means I'm going to move it right 1, and the minus 3 out here means I'd move it down 3. So 2 to the x moved right 1 and down 3. So you just talk about what basic graph you're starting with and what you're doing to that graph. And like I said, all of your rules for transformation can be found back in section 2.4. So you may want to review that, especially when it comes to vertical and horizontal stretches and shrinks. That kind of gives people trouble sometimes. I think that pretty much covers it for section 5.2. You do have some word problems that you're going to want to look at, and if you have trouble with that, then let me know and I can do some examples of those word problems for you. All right. Make sure you get your homework done. Section 5.2, which is today, it would be problems 27, so section 5.2, problems 27 to 67 odd. So we're looking at about 20 problems, maybe 21 problems for tonight, but they're really not too bad. For most of them, you're just answering how you shifted it. These are 3 problems right here or something, so it'd be pretty easy. There are some compound interest problems, but you're just going to plug in and evaluate in those. So let me know if you have trouble, and I'll try to help you.